Okay. No. I don't know where the potential, I think it's the chapter 18 stuff. So we did one of the 5s yesterday. Did we do both of them?
We tried to do one of the 5s, but we said that we didn't.
Okay, yeah. The first one we did, and then the second one was like, oh, that's a different topic. So that would be a good thing to wait till tomorrow. So that means that's a good place to start today. All right. So we got 2 stationary charges, or separated by that. It's released midway, moves along the line. Okay, yeah. So what is the electric potential energy of the electron when it is at the midpoint? Okay, this is still actually potential energy rather than just potential, but that's okay. So again, it's just going to be the QQ over R. Do that for both of them, and that's it. So we've got 4 and 2 separated by 60 centimeters, and you've got an electron. So you got 4 times 10 to the minus 9. You got 2 times 10 to the minus 9. This distance is 60 centimeters, so 0.60. And you've got an electron there. Yeah. Moves along the line. When it is at the midpoint? When is there? Okay. So for the first one, I mean, again, both of them you're just going to go K. So K is 9 times 10 to the 9. And then times 4 times 10 to the minus 9. Then times the charge of the electron, which is 1.6 10 to the minus 19th, over the distance, which for the first part, it's in the middle, so the distances are both 0.3. And the same thing for the other one. Well, 4, 2 times 10 to the minus 9, 1.6 times 10 to the minus 19th over 0.3. And then the last thing we need to decide is, I mean, thankfully it's not vectors, so we don't have to do i's and j's and whatnot. But even with numbers, we do have to think, okay, are these going to actually add together, or are they going to subtract? What do you think? Are they going to add together, or are they going to subtract? Why do you think they're going to subtract? Yes, the midpoint. What's this charge over here? What does it want to do to the electron? Yeah, it wants to pull it this way. What does the other charge want to do? Does it pull it left or right? Well, yeah, I mean, it's wanting to pull it right, but it's going to lose. I mean, overall, the electron's going to go left. But I mean, the point is, like you were saying, they're working against each other, so that's why it's going to subtract. Right. If the charge on this right side was negative, then it would also be pushing it left, and so then you would have to add them. But so we're going to subtract these two numbers, right? And so let me grab our calculator app that we've grown to hate, because it's not as good as a real calculator, but it's okay. It's what we got. So we got 9 times 4 times 1.6. Actually, let me just half that. So for the first one, since the denominators are the same, the 4 and the 2, they're just going to subtract, so it's not really a big deal. you got 96 times 10 to the minus 19th. So 9.6 times 10 to the minus 18th. Nine point six times 10 to the minus 18. Oh. Let me type that again one more time. Okay, so 9 times 2 times 1.683 is 96. Okay. I'm going to try this just to be on the safe side. I can't imagine that being right. Oh, it is. Okay. Our intuition was wrong. You do add them together. Just, it feels weird. Because the forces are definitely opposite of each other. But, okay. So if you add them, you get the right answer. For part B, it's the same thing. The only thing that's changed is instead of putting it in the middle, you're putting it 10 centimeters from the 4 Newton charge. So that one will change to 0.1, which means that one will change to 0.5. But otherwise, the problem's exactly the same. So, cool.